everyone. My name is Matthew Kellinger. I'm a co-founder of Element Biosciences, and today I'm here to share with you some of the innovations and products we're bringing to the market in 2023. What I want to talk about mostly today, is the data and the new products that we're releasing this year, right? Mostly Cloudbreak chemistry, so new chemistry on our platform. But when we came last year and released the AVITI system, we came with the promise of have it all with AVITI, right? This idea that the sequencer that we were bringing, really, adding sort of more competition to the market, providing more options, and really giving unsurpassed levels of flexibility, performance, and cost all together in a package that spans output options really across most sequencing needs in a rather diverse field. As adoption has picked up, what we found is that AVITI is actually the right sequencer for many different markets. Initial customers, some of them lent their names to this slide, really span the big umbrella of genomics that we all live in, right? Across many different sectors, sizes, focuses, AVITI is the right system for a lot of those needs. And so when a purchase of an AVITI instrument is made, the first part is we've got to get it to you, we've got to get it installed, we want to get you up and running with sequencing as fast as possible. Some statistics on performance in the field, getting the instruments there and set up. Largely, this has been a huge success for us, installing the instruments, having them work right out of the gate, and keeping them working as customers start to collect more and more types of diverse data. And that's really what it's about, getting to that data. And our data quality is pretty exceptional. In terms of a Q30 spec, over 90% Q30 versus 85% on most Illumina offerings. There's also differentiators inside that sort of umbrella of high quality data, in that we see much lower index hopping than the Illumina platforms, lower optical duplicates because of our amplification, and something I have a slide on a little bit later around homopolymer performance, which was pretty interesting to us when we first saw that data. But I think it's worth taking a moment, sort of stepping back and looking at how avidity sequencing works. So what we've done, and I link the rather large QR code, goes to a paper we have on bioRxiv right now, which is in peer review process, which describes our technology in much more detail than I can do today. Basically, the fundamentals of avidity sequencing are that you separate detection from stepping, from getting to the next base. And this has advantages because on the enzymology side, on the reagent development side, I can really tailor each of those functions, which are quite different, to their specific tasks versus traditional SBS where it's together. Additionally, our substrates, the avidites shown there on the bottom left, are multivalent substrates, which allows for incredibly high discrimination and stringency in base calling, adding to that high quality data. That's the main driver of why the data quality is so high. So this was a good initial reagent scheme, what we went out with, and what we promised were really two things: that this chemistry was at the beginning stages of its product arc, there would be a lot of innovations to come, and that we would continue to innovate very, very quickly. And now, 9 months later, I want to talk about some of the metrics around our Cloudbreak chemistry, which works on the AVITI platform. So Cloudbreak, again, is a new reagent version, and what it delivers is 10-hour faster runtimes. So we've gone from 48-hour runs to a more comfortable 38-hour run for 2x150, maintaining that high data quality, if not improving upon it. We've also made a few advances in terms of the workflow itself. We've moved indexing to the very front of the workflow. The data quality is so high that we can put indexing up there. And what that allows for in LM Bio Cloud is an early demux report to be generated about 5 hours after a run starts, where you can see the breakdown of how your indexes are assigned, get all those bin numbers. It's better to get that early than find out after a sequencing run that things weren't balanced. So we were able to make that change. Additionally, around circularization, for our library prep workflow, for the Elevate workflow, and I'll go into that a little bit later, we've enabled onboard circularization. So now you can load linear libraries directly onto AVITI and have the automated process inside the instrument convert those libraries and start the sequencing reactions. And of course, some of the performance behind Cloudbreak chemistry is our commitment to new enzymes, so 2 new enzymes that are doing the sequencing, as well as advances on the engineering side, which allow us to image faster. And if we look at the breakdown of the runs, what you can see is that 10-hour savings, right? Really starting to have the AVITI workflow fit comfortably in a 2-day work cycle, where you can start that second run on that, or start another run on the second day comfortably during a shift, and moving the indexing up front to be able to generate that report. So the 38 hours is really the top line performance of the instrument. There are other configurations, and the system itself is flexible enough where at 2x75 runs with less data output, you can be down at 18 hours. So, a big thing we wanted to do is keep the system very flexible and keep the run costs low. And this just shows sort of, depending on what you favor, how much data out you want, how long you want to spend sequencing, there's various workflows in there that enable that. So on the library prep side, I did mention the on-flow cell circularization. We maintain 2 streams of library into our system. The first is the adept workflow. This workflow works with every commercial third-party library prep workflow we've tested to date. It does have that circularization module, that's additional library prep to circularize the libraries before you go into the sequencer. And the Elevate workflow still leverages a lot of those commercial library prep kits that you're currently using. You just get the adapters from us and swap them, still use that same protocol, and then you end up with linear library, which can go directly into the box. And the way that works is once you have linear library, the library comes onto the flow cell, it hybridizes, the ligation happens, forming a circle, then you're off to amplification and then right into sequencing, right? Taking that contact time and that extra library prep out of your hands. Data quality, I think, is something that we tout, and when you get into sequencing with the new Cloudbreak chemistry, what you find sort of direct head-to-head is that the chemistry performs extremely well. Right, so even last year's chemistry, our V1 chemistry, was considerably stronger than both NovaSeq and NextSeq, with the majority of bases with mean Q scores up in the Q40s. Cloudbreak continues on that and really increases the performance of Re2, adding robustness there, and as you can see, maintaining those high quality scores all throughout the sequencing run, all at faster times and with that simplified workflow. So as we get into looking at some sort of downstream secondary analysis metrics, I'll show you what human builds look like with the Cloudbreak chemistry. So here's a space where you have to be really careful about how we compare, right? Library prep has a huge influence on the quality of the full human builds you get. So here we were very careful to do many repeats looking at the exact same library, our V1 chemistry to the Cloudbreak chemistry. As you can see, we're maintaining that performance, if not improving upon it slightly, with only about 30,000 errors across the whole genome. So, GC bias is another thing that's extremely important. We've looked at that as a function of SNP F1 scores. And what you can see here, very flat through the region where a majority of SNPs lie. But even out at the edges, Cloudbreak has improved over last year's chemistry. So better performance, pretty uniform performance all throughout the GC windows. So one of the places as we started to get more familiar with our own data, look deeper, was around homopolymers. And as I look at homopolymers, here's some data. What we found is, looking at both, again, NovaSeq, NextSeq, our V1 chemistry, and Cloudbreak chemistry, if I look at that plot on the left, before a homopolymer, so the left side of that left plot, that's relatively easy to sequence real estate. The technologies, all do extremely well there. What we find is when you get to that bar at that position 0, that's been set at where a homopolymer ends, we find that avidity chemistry fares much better through those regions and really coming out of homopolymers with 5x less error. It's fair to ask, did we cherry pick this data? And we did not. That plot on the right shows every homopolymer sequence in the human genome stacked up and binned, and what you can see is a vast majority of all homopolymer performance performs better on the Element platform than Illumina platforms. If I look at some other applications, we can look at exome performance. So we did this with Twist. The top line conclusion here is sort of what happens above 0 on the y-axis, right? Both platforms make the correct call in exomes around variants that are there. The difference becomes in how easy that is to do with downstream analysis. So the data being cleaner and higher quality means less candidate false positives, as you can see in those blue bars. There's less to have to sort through to find the correct answers. And if we look at that pan-cancer panel performance, what we find is something we noticed last year and we did more investigations into, is that you don't have to sequence as deeply to get to the same answer on the AVITI platform. Again, because of the quality of the data that's put out. And then panels like this is where duplication matters. You don't want to be throwing away any data to duplication. We have significantly lower level of duplicates, which lends itself to that performance. Something we talked about in our lounge this morning, Sean Levy's talking about it later tonight again. I'll talk about it for a third time because I think this is pretty cool, is insert length in your library and what a phenomenal tool that can be to improve overall human builds. So we asked, what are the limits of our chemistry? And we made libraries that were increasing in size with insert sizes on median at 1,000 bases. We still did 2 by 150 sequencing. And on the left there, what I'm showing is actually aligned insert lengths off the sequencer. We can generate polonies that contain these large fragments. Some of these sizes were actually over 2 kb. And the real advantage of that, and this ended up not being a surprise to us because we did the simulations before we did these experiments, where you can take those longer inserts, even at 2 by 150, and have a much easier time aligning them to the genome. As a result, the data quality gets better. SNP and indel false positive and negatives come down. And that's a full 25% better than the NovaSeq currently. So that's Cloudbreak coming for this year. There's also been a ton of interest in 2 by 300, right? This is something that we wanted to use Cloudbreak as the foundation for, and then immediately start working on how we improve our 2 by 300 performance. I can show you some of that data, and this is still early. It's in research and development, but we plan to launch 2 by 300 kits at Q3 of this year. So in terms of performance, we believe this is already very good, useful for many applications in the 2 by 300 space. A big feature of this is we're generating 400 million reads at 2 by 300. So a lot of data, significantly more than the competitor platforms currently on the market today. And I ask you, maybe a little interactively, to reach out to us if you're interested in 2 by 300s and AVITI, particularly that email address. Send an email there. We'll be in contact, and we'll find a way to work together on early access, getting it out even before the Q3 window. So in the last 5 minutes I really want to go through sort of some of the economics of running and using an AVITI sequencer. We put this calculator up on our website towards the end of last year, right? Really showing customers, potential customers, how much you can save over a NextSeq 2000 if you purchase an AVITI instrument. It turns out it's over $1.7 million in 3 years, right? Think about what you could do with that money and those research dollars. In truth, even if you're getting a discount from Illumina on the instrument itself, $50,000 off, 25% off reagents, what we find is that you still come out ahead with the AVITI platform because its operating and run costs are so much lower. It takes 6 months, even if you get a free NextSeq 2000, to cross that line and be in a lower operating space with an AVITI. So it's not just against the NextSeq 2000 where performance and economics stack up really well. It's actually, we designed the system to be able to flex across really the whole portfolio of sequencers that are out there today. First, against the MiSeq, what AVITI offers is the ability to put it into a low output mode. And what this does is offers 125 million reads, so about 10x the amount of data, but does it for considerably lower costs per G at about the same runtime and higher data quality. If we look at NextSeq 550, AVITI can be put in a mid-output mode where it runs in 31 hours with Cloudbreak chemistry. Now here you're generating 100 million more reads than the NextSeq 550. Again, a significantly higher data quality and about 4x lower cost per G. If we look at the NextSeq 2000, With Cloudbreak chemistry, we're now 10 hours faster, right? 1 billion reads in one flow cell versus 1.2, so there's a slight difference there. Data quality higher on AVITI, and again, operating costs are lower. And there's a path to $2 per G, which I'll show in a moment. If we start to look at the higher output sort of factory level systems, what we find is with NovaSeq 6000 in the SP flow cell, in one flow cell on AVITI, we're generating more paired end reads. There's a trade-off here for time, but again, data quality exceptionally high. We're always going to err on the side of exceptionally high data quality. And again, we're about twice the, 2 times less in cost per G, with again that path to a $2 cost per G. Finally, around the S2 flow cell on the NovaSeq system, now here, the NovaSeq generates a lot of data, right? If we run both sides of our instrument, we can generate 2 billion reads using 2 consumable kits. Comparable in terms of runtime, still costs less per G. Data quality, still higher. So finally, I'll conclude around our $200 genome announcement. So we did this earlier in January. The way this program works is a commitment to a number of boxes and a volume purchase on reagents. The boxes do not have to be co-localized inside your organization. So if you have a facility on either side of the country, they can both work together to sort of fulfill those requirements. And based on those numbers, that's how we can get to $200 per genome. It works out to $13 per exome, 60 cents per million read. It's an option that's available today. And I want to be super clear about there being no sequencing application sort of restrictions. Use the reagents, sequence whatever you want, sequence as much as you want. I think I conclude there. Thank you very much for your time. I'm excited to bring this technology to everyone and get into AVITI.